Okay, so I think we have been discussing about the test, right? That is due on 10th August, right? Which will be your class, right? On the class day, which will be your last class day, as discussed earlier. So it will be a 1 hour test. It is 40 marks. You have 10 MCQs and 3 summative questions, right? Summative questions will be something like you need to explain, right, a concept or a technique or a technology, right, or discuss on some of the concepts, right, or maybe any small problems. I think we discussed about those things in our lecture, right? So totally it will constitute to 40 marks. So it will be on our lecture class. Okay, so on that particular day we'll be having this test, right, and then we'll have the lecture on data governance, right? It's a very small chapter, and then we can have a discussion on that particular chapter. So I'll be asking about how you're being doing in your organization regarding data governance, and then we'll have a discussion on that particular chapter. So this is what we have been discussing so far regarding the test, and then based on your interest, right, you've been asking for the mock test. So next week, right, I think next week we have a class on Wednesday, right? So this the 10th August is next week, right? Okay, so can anyone list down the classes of, or we have a class today and then we have a class on Monday, right? Monday and then Thursday. So which will be on 3rd, 8th and 10th. Am I right? Sorry, 2nd, 8th and 10th. Today, 8th and 10th. Very good question. It is 20%, no doubts. Right? Our mark is 40 marks. It will be capped to 20. Don't worry about it. Okay, the system will take care of it. Wong Si Hong. Are we clear? Okay, thank you. I think in percentage, I think we have made it very clear, right? It's 80% assignment, 20% is test, but the mark for our test is 40 marks for 1 hour. Okay. All the conversion will be taken care by the Moodle, so nothing to worry about it. Yes, 2 classes left, right, on 8th and 10th, which is Monday and Thursday, right? So our mock test will be on 8th. The mock test will be like 30 to 35 minutes, right? So you'll be having like 5 MCQs and maybe like 1 subjective question. Okay, are we clear in that? For next week's mock test on 8th. 8th is mock test, 10th is our final test, right? Can I get some feedbacks whether it's fine? Okay. Okay, fine. Yes. How long of the sentence is expected for each summative question? Very good question, right? That's the reason why we put it as 40 marks, right? Because if in case we put it as 20 marks, it looks very small, right? So then they think that maybe we like the very small. So each question carries 10 marks. So we are expecting and answer for 10 marks, which be something around 200 words for each question. Right? 150 to 200 words. Yes, you lock. Right? So 200 words, it is just to make sure that we have an understanding, right? You can write 250, 300, 400, no issues. Any other doubts? Feel like hard to complete within 1 hour? No, it's not hard. It's already been tested. It's practical. Okay. No, please make sure that there's no references. Okay, it is mainly, it's not an open book, it's a closed book test. So make sure that you write in your own words, right, on your understanding.
Sorry, sir. Is it we cover the SAS scripting? I mean, the questions, something got to do with the SAS.
No, because here we are talking only about CLO1. Evaluate various data types, data storage systems, associated techniques for indexing and retrieving data. So when you're talking about evaluate the various data types, we'll be discussing about what we discussed in our data types, right? What are different data types we this studied, NOIR, normal, ordinal, right?
Oh, okay.
All those things you
Noted.
just remember, structured, unstructured, about different types of methods we used for some purposes, like we use many things like what is mean, what is average. All those things are pertinent to this particular concept of data types, right? And for data storage, you can very well discuss on our understanding on Hadoop, HDFS. So these are going to be the areas covered under data storage. For associated techniques for indexing and retrieving data, right? Here we'll be discussing on the Hive platform, right? The architecture technique involved. Okay, are we clear? So there will be no coding involved. No need to write any codes, right? Even for Hive, there's no need for writing any SQL, right? It's purely theory. Yes, you're right. You need to open camera when you do the test. Yes, thank you, Lakshan, for giving the note here. Thank you. Okay, so hope we are very clear. And regarding assignment, I'm sure all of you are progressing well. Yes, Angpo, no issues. You can use a different laptop. Okay. Any other queries? Hope everybody is clarified. Can we do some lecture? Right, because these lectures are mainly for our test. Like what we discussed for this class and next class. Okay, this test is you don't have turn it in. Okay, this is mainly for after you submit. Okay, we'll be checking for plagiarism from our side. So please don't plagiarize. There's no need for you to check for plagiarism. We'll be checking for plagiarism, whether it is a cut, copy, paste. Right? Are we clear? Okay, thank you, Angpao. Hope others are also clear on this. Yes, any doubts?
Hi, sir. Sorry. Yeah, I actually have some issues with my laptop. Because previously when I was doing exam, if I have Teams open and I try to open access Google Chrome and then Moodle, it starts lagging and I cannot use Word document and all sorts of things. So now that we have to open camera, I am not sure how well my laptop will be performing. So yeah.
Okay, no issues because next on Monday we have a mock test, right? So you can test on it.
Okay.
If still there's a problem, then maybe you can have another laptop for that particular session.
Other laptop, I only have one.
Because
Yeah.
for the test, okay, please be minded anyway, because during mock test you'll be having these details taken. When you're taking the test, you are not allowed to open any other browser.
Okay, but the answers are on.
It not allow. You have to answer only in that model.
Okay. Okay.
There is no need for you to write in any other piece of document and then upload. Everything is to be written inside the model. For MCQs, it is just you need to check the answers, and for the summative answers, you just need to type, and then there's no even you just have to write the answers. That's all. It will automatically submit.
Oh, okay. Yeah, I guess I'll try it first on during the mock and see how it goes.
Sure. Thank you.
Thank you.
Okay, fine. So maybe later after the. Oh my God. Chitio Kalib, 10th is not a mock, 10th is the final. Okay. That's why I recorded and I also put it in the writing. And I think you, Lokshan, also had it. Give another more feedback over there. How about referencing to our own notes or any remarks at the lecture slides? Referencing for test answer, is it? Wang Shao? No. For test, there is no need to reference. It is just your understanding, what you have learned, what is your input. Okay. Thank you. So I think last class we discussed something on data warehouse, right? Okay, Caleb. Caleb is getting doubt once again. Okay, no problem. We'll copy paste the same thing here, but not doing the test, only here. Okay, Caleb, are we clear? We discussed this earlier. Anyway, for your clarification. Okay. Mock test is just because some of your friends wanted to have a mock test. Okay. I'm really not interested in mock test, but because your class insisted, okay, I don't want to go against it. So we mock test is on 8th. Mock test is just 35 minutes. Just for you to get clarified. And on 10th, it will be 1 hour test. Okay, Caleb, are we clear? I want everyone to be clear. So I don't mind repeating it, but I just want to make sure that everybody is clear on this. Right, so maybe later I'll put it on. I'll put it in the Moodle posting as well as here in this Teams also, so that anybody who is driving or taking dinner or sure we focused in their office work, they're also once again aware of it. Right. Okay, so can we start the lecture now, or maybe we can have a small break and then start it later? How are you people feeling now? Maybe we can have a small break now and then start, and then later we can have another break in between. Just 10-15 minutes break. Okay. Okay, sure. Okay, I'm sure because many of them are already feeling tired. Okay, no issues. So now it is 7:40. Okay. It's 15 minutes break so that we can have another break after maybe 1 hour of class. Okay, thank you. It's just a 15 minutes small break. Thank you. class. Okay, so hope you're feeling more fresh. Okay, so regarding the test timing, so all of them are here. Yes, okay. Still some more. Okay, no issues. Because I'll be putting it now in the Moodle also so that everybody is being posted. And I also want to get some feedback from your side. So for the test, for the mock test, which is on 8th, it's a 30 minutes test. So it will be from 8:50 to 9:20, right? After our class. So that we finish our class for that particular session on 8th. Okay. So the test will be 8:50 p.m. to 9:20 p.m. For the final test, we'll be having it prior so that we complete the test and then we go for the last chapter, that is the data governance. It's a small chapter, right? We can discuss that on that particular day after the test. Right? So it will be from 7:15 p.m. to 8:15 p.m. Right? Are we clear? Everyone? So those who are in here, I can just name them: Lee, Tian, Shanti, Lee, Lok, Sabrina, Kalib, Leok, Ang Pao, Juan. Okay, very good. Okay, I sent the message through Moodle. Kindly check if you receive the message. Again, kindly feedback here. Did you get the message from the Moodle? No, there will be no connectivity issues because everything is online, right? Once you're connected, it will be automatically submitted. Okay. Usually we give 5 minutes buffer time. So maybe that can be applicable. Okay. Okay, very good. Done. Is it through Moodle or you got it through the email? Done. Got it in Moodle. Okay, very good. Thank you. I'll once again put it in Teams also for those who are not yet logged in today. Okay, thank you. Okay, so can we start with the Hadoop? I think data warehousing is complete, right? Any thing still missing in data warehousing? Angpo? I think the last class, I think we discussed many things on data lakes and data warehouse. I think there was a discussion going on, right? Whether it's still data warehouse or something. We discussed still data cube. Okay, good. So we'll discuss that. We'll make it fast. And then we'll go with Hadoop. Hope everybody can see the screen, right? Okay, thank you. Right. So this is just a recap of what we discussed, right? Of data warehouse. On overlap concepts, right? And key terms regarding OLTP overlap, star schema, Snowflake schema, fact constellation processing, analytical processing, right? So we define data warehouse, about subject oriented, what is integrated, time variant, non-volatile, right? And what are the organizations that are really trying to use this type of system? How we distinguish OLTP and OLAP? Why we separate data warehouse from a typical relational data warehouse? Data based systems, right? Our 2D, 3D structures and the different ways in which we are trying to bring information from them. So regarding from tables and spreadsheet to data cubes, right? So data cubes as such, we are trying to envise what we bring it from multidimensional data model view to a form of a data cube. So data cube for an instance as a sales data allows data to be modeled and viewed in a multiple dimension. Okay, so this is just a concept that we are trying to bring into our understanding, right? So it allows us to be modeled and viewed in a multiple dimension. Okay. So in dimension tables such as item, we can have item name, brand, type, right? Or the time, right? So the day, week, month, quarter, year. And this could actually be helpful for us to bring out the relative information pertaining to the particular period. Okay. So the fact table contains measures such as tangible values that we are trying to talk about, okay, like dollars sold, yeah, keys to each of a related dimension table. So when you're talking about schemas, we'll be having this discussion on the fact table and the dimensions. So in data warehousing literature, an ND base cube is called as a base cuboid, right? And the topmost is called as the 0D or the 0th dimension cuboid, which holds the highest level of summarization. And is also called as the apex, right? So just to take note of the key terms, right? What is called as a base cuboid, what is the apex cuboid, and what is a data cube? So lattice of cuboids forms a data cube. I think we discussed this about lattice, right? How we are trying to bring the collection of cubes to form our lattice, right? So a simple structure of a lattice of cuboids, right? So you just need to visualize in way of how we can bring n number of cubes to form lattice of cuboids, right? So here we are talking about 0 dimension, 1 dimension, 2 dimension, 3 dimension, and 4 dimension. Right? So if in case you remember the values that we were discussing on the dimensional approach, right? Like here, the values of item, right, and time over location. In 3D, talking about the item, time, and the different other locations, right? So we are trying to portray in a 3D cube. In a 4D cube, once again, we are trying to have more number of these summarized to form the lattice. So this is actually a conceptual model of data warehousing on dimensions and measures. Okay. So here we are only concentrating on these 3 different conceptual models, namely star schema, snowflake schema, and fact constellations. So in star schema, it's a fact table in the middle connected to a set of dimension tables, right? So we can have a simple look at this particular type of an schema. So here we're talking about a star in the sense like how in a star, right? Like we can have different dimensions. So here we're talking about the fact in the middle and the dimensions in the other locations, giving an attribute type of a functionality. Okay. So here we have 4 main attributes like item, location, branch, and time. So each one is located and pointing towards the sales fact table. And we have the measures, which gives the measurable value, right? So units sold, dollars sold, and average sales. Okay. So a fact table in the middle connected to a set of dimension tables. Similarly, in snowflake schema, you can just visualize like a refinement of a star schema where some dimension hierarchy is normalized into a set of smaller dimension tables. So we are getting some key value separated from the main attribute. So something like this. Okay. So before we had only supply type, so we are trying to get more detail about supply type, maybe supply key and supply type, or maybe if in case from city, like what are other details from city, maybe like city, province, or country. So we're trying to normalize the data. So in that case, we are trying to go with a snowflake schema and fact constellations like multiple fact tables, shared dimension tables viewed as a collection of stars, therefore called galaxy schema or fact constellations. So what I'm trying to ask you here is anybody still using these types of schemas in your office, or data warehousing is still existing in your platform? Well, I think last class we discussed more relatively on data lakes rather than data warehousing, right? Angpao?
Actually, we get the whole thing something like data cube, something like that, and then from the data cube we have two things. One is dimension, one is other fact table. So these are the things that I know. And then inside the data cube from sales department one, and the other data cube from another department. So something like this thing that I can see from the Power BI. So in terms how
relate them.
Sorry, sir.
You can actually relate them, right, with your.
Yeah, correct.
No, thank you.
Thank you, sir.
Okay, how about others? Is everything clear? Any doubts so far? Okay, so just try to get the theoretical understanding. Right. So in star schema, the most common modeling paradigm is the star, right, in which we are talking about a fact table and a dimension table, right? So these two are the important entities in a star schema. So fact table is nothing but central table containing the bulk of the data, and there should be no redundancy, right? And in dimension table, right? So we have one for each dimension, and the schema is going to give a detail about the table, right? So it can have a radial pattern around the central fact table. So this is what we have been discussing. So instead of like schema, we are having, if in case any data need to be normalized, the attribute retest can be populated. So this is the example of a fact constellation. So I am sure all of you are well aware of what is the meaning of constellations, right? A group of stars, right? To form a some sort of a figure that we are making it as, right? Like Leo, right? Or what? It's like, I think you name, right? In when you see a group of stars being combined together to form a constellation. Similarly, that is what we are trying to put here in this approach, like more than one star combining to have clarity on the data that has been collected so far.
So can I ask you one question?
Yes.
The previous slide, yeah, this slide. I saw that there's a space being replaced by underscore. Is this a naming convention for variable, or can we use blank space instead of underscore to connect the two words together?
Okay, this is actually a naming nomenclature, right? When you're not supposed to have a space, right?
Inside our database, we can put space, but we need to put something as single quotation to make this whole thing as a variables.
Oh, yeah,
But,
yeah. No, that is okay. But here
I
you're
see.
trying to just give us an understanding about space not being allowed. Okay.
Oh, okay, got it. But in practical, we can use this space instead of underscore, right? Depends
But once
on
again,
our.
it depends on what type of language you're using, right?
Oh, okay. Thank you, sir.
Thank you. Okay, very good. Okay, now regarding the concept of hierarchy in dimensional locations, right? We're talking about bringing this understanding of the dimensions, okay, in picture, like having all, right, which is a 0 dimension, which has the more more dimension, right, in space. So all, and then from all we are talking about the regions, and then countries as such, and then cities and offices. The typical view of arrows and hierarchies. Okay. So I'm sure some of them would have already been explored to these things. This is just a screenshot about the real time. So this is a DB minor, okay, view of a typical data warehouse. The multi-dimensional data like sales volume as a function of product, month, and region. So putting it in a dimensional space where you can have it as an industry, category, product, or a region, country, city, or office. Okay. So don't need to worry about these things, like you will not be getting any complex questions regarding their multiple or dimensional data, right? Don't worry about these things. This is just for your understanding. Simple data cube, okay, view of your sample data cube. Like all, right, which is your 0th T, like how we had discussed about this one, right? This is the 0 dimension, right? And this is first dimension, second dimension, third dimension. Right. So here in all, we're discussing about the dimension space. So you can just visualize as a cube in 3D structure, okay, and just see like how we can see different phases of the data. Right. So cuboids correspond to the cube, right? Are you able to understand this concept, what we are trying to do here, like how we are trying to figure it in terms of a cube? So in a typical OLAP operation, we can do a roll up and drill down. So in roll up, it's all about summarize the data by climbing up hierarchy or by dimension reduction. Right? I think most of these things we discussed in our science, like dimension reduction, we can go for summarizing the data, right? And for drill down, it's like reverse of the roll up from higher level summary to a lower level summary. Okay, and we can also introduce a new dimension in this particular approach. Right. So data warehouse design process. We can have both top down and bottom up approaches or a combination of both. Right. So when talking about top down, we're talking of starting with overall design and planning, which is a matured approach, and a bottom up starts with experiments and prototypes. Okay, so these are just about different approaches that can be used, okay, when having a design process. And for a software engineering point of view, waterfall model, like structured and systematic analysis at each step before processing. Right, if in case you are aware of software engineering process, right, so we cannot have something like a rolled up thing. So it is always structured and systematic analysis that is to be done at every step before proceeding, so that we don't need to come back, or it is not actually usually allowed in this type of a model. So in spiral model, right? So it is just for you to remember in case you are from that particular background, or nothing to worry about. So we have this type of models like waterfall model, spiral model, to give us an understanding about what different type of design phases can be argued. So it's a rapid generation of increasing functional systems, short, right? And it is very quick. That is one of the very beauty of this, right? I'm sure most of these things are not being used nowadays, right? I'm maybe using rapid or agile. Am I right? Anybody in this particular field?
So I don't think most of the companies here actually practice this. Because data engineers are mostly new hires now. I don't think
Yes.
I don't think the institute is producing enough manpower for this field.
You're right.
So
And I think
I
most
would
of them
say
will be
spiral-
using the agile methodology, right?
yeah, I think spiral is more suitable. Right, new hires just when it comes to us. I mean, when there's a new task, we just Google and try to build a query and let it run. That's it.
And also they also go for the Kanban method, right? Kanban.
I think mostly agile. I mean, in my company is agile.
Yeah, so this is just for our theoretical understanding, okay, for data warehouse purpose. Okay. Anyway, don't worry, these things are not going to be tested because of the validity. Okay, so the typical data warehouse design process, we are talking about the business process as such, right? And then the grain, which is the atomic level of data of the business process, and the dimensions, right? What we discussed in the schema, like both dimension measures, which are going to be used for applying the fact table or for populating that particular fact table values, right? So this is the overall multi-tiered architecture where we have the data source, right? And from the data source, we are trying to put inside a data storage through these functions called ETL, right? Extract, transform, and load, right? So through this, we are bringing the data into the data warehouse. And when data warehouse, we are much interested in the data marts, which is nothing but subject oriented data, containers as such, and then metadata, which is going to be data about the data. Okay, and then we have monitoring and integrators to make these things possible in a way suitable for this architectural design. And lastly, we have the OLAP engines to serve the data warehouse through a OLAP server, and the ETL, after being highly useful in this particular purpose, right? And then after getting it to service, then we are going with our BI tools, right? For getting the reports, right? You can use analyze, query report, or even data mining can be done with our historical values in our data warehouse. right? So this is one of the reason why we are putting in terms of volatile or non-volatile data. So the two data warehouse models, right? We can call it as enterprise warehouse or a data mart. So in enterprise warehouse, it's collection of all the information about subject spanning the entire organization. So in data mart, it's once again based on the groups, right? That is the reason why we put it as a subject oriented one. So it's based on the department, maybe it is sales, right? Or maybe it is finance or purchase. So each and every department has their own data marts, right? So how we are trying to put it in a flow chart. In the base, we are trying to get a high level corporate data model, right? Which is getting and giving data to the data marts, and the distributed data marts will once again liaise with the multi-tier data warehouse, which in turn gets entangled with this enterprise data warehouse, right? Okay, so regarding this picture, can anyone give us some understanding on this? Okay, it's just like something to discuss. If this is very clear, then the whole chapter what we're discussing is fine. Okay, very good. So that is the reason why I wanted to put this in focus. Any inputs from for this distributed data marts in real time? Yes, Chupan.
Yeah, so my understanding is that every department has its own data mart, right? So basically, they made up this distributed data mart so that it can be accessed by the other departments. I'm not sure. But what I understand about enterprise data warehouse is that it's a common data set that maybe every department can apply, right?
So this enterprise data warehouse, can we call this as a central store?
For example, like employee ID, things like that. Can we call it enterprise data warehouse because it's commonly used by the whole companies, right?
Can. It's once again depends on the logic or what we call as the guidelines proposed by that particular architectural designer.
That's true.
Right. Okay. So what we are trying to say is very true, right? Like what Chupak is trying to give us in detail, right? Like data marts, because of its nature, because of subject-oriented nature, right? We need to have some sort of understanding so that all data marts, or maybe some data marts, are being distributed in nature to get or to collect information from those subjects or from those departments, right? And this is why this is how an enterprise data warehouse is actually being subjectively run, right? So there is no big confusion here to understand like why this is to be like this. This is the architecture design to make sure that those data that is really pertinent to be inside the department, right, are hold safe, right? And I'm sure that these things are really to make sure that we don't go into the concept of data silos, right? If this is very clearly understood and it is really clearly mitigated, then data silos will not happen, right? Are we clear on this? Right? Any other further discussion? Any doubts? Are we clear in this? Okay. Can I get some feedbacks here? Yes, something like that. Okay. Aggregation of multiple data marts needs to be done so that we are having some sort of integration between among the departments. Without that, we really cannot have an enterprise, right? Lucian, are we clear? The reason of having data marts and the reason why we need to have a distributed data mart. Okay, thank you. So this is the data warehouse usage. So we are very well aware of where we can use this, right, for information processing, for valid querying, basic structural analysis, right, for reporting and all those purposes, and for analytical processing, like for OLAP, slicing, dicing, right, pivoting, and all those things. And for data mining, of course, it's all for discovery of hidden patterns. It can through classification, prediction, or any visualization tools, right? Okay, I hope all of you were clear in this. So just now we have some questions on this. Okay. Can we go to the next slide now? Any doubts so far? I think this is just a session of what we discussed last class, and then to make sure that we are having some good understanding on those schemas and then about the architecture as such. Okay, class? Okay, before going to Hadoop, can we get some understanding about what is Hadoop and why Hadoop? Yes, I think everybody can give some discussion on this. Why Hadoop? Yes, Angpao, to handle big data, fine. Do we need to draw any architectural diagram for our test? No, no need. Okay, for big data storage, yes. Yes, Deepak?
Distributed storage. Distributed
Yes.
storage.
Okay, we have some common name that is usually used to address Hadoop. Are we aware of that? Anybody? Yeah, parallel distributed storage and processing. Good, fine. Whenever Hadoop. Yes, thank you, Lokshan. We talk about MapReduce, HDFS. Very good. Have you come across this term, commodity hardware? Commodity hardware. Right, okay. So we call it as cheap hardware because it is more commonly available and is more available, right? So it is something like you can use this commodity hardware, right, and have an Hadoop architectural design or Hadoop system be made, and it can also have this advantage of scaling up or scaling down based on the needs, right? Okay, thank you very well. So here we are trying to discuss on what is Hadoop, all right? Hadoop framework, architecture, Hadoop in the wild, data warehouse to Hadoop. Okay. So please, I'm sure many of you or most of you would available on the reason of this particular what we call as this, the elephant calf, right? This toy. Why? So maybe later you can do a Google search of why this is the symbol for Hadoop. Okay, so this is actually a product from Apache top level project. It's an open source. Okay, and it's mainly for its advantage of being reliable. Right, we need to happen to the pin. Okay. Right, for reliable, scalable, distributed computing and data storage. Right. So it is a flexible and highly available architecture for large scale computation and data processing on a network of commodity hardware. So when we talk about commodity hardware, we're talking about commonly available resource. Right. So please take note of this. This is the reason of Hadoop becoming popular extensively for the big data. So it is designed to answer the question, like how to process big data with reasonable cost and time. Right. It all started with this web crawlers, right? What is web crawler? Nothing but the search engine. Right. Initially, we called them as meta search engines or meta crawlers as such. Before, maybe I'm not very sure like how many of you would have used these search engines, but we were used to go only with meta crawler before actually Google, all those things were becoming popular, right? And we usually used only Yahoo search engine, right? Before that. Okay, fine. So the reason why I'm specifying Yahoo is because they also have collaborated in this particular platform. Right. So in 1998, Google and released that beta, and then in 2013 they had this version. Okay. So in 2003, the Google file system, right, was named as the Hadoop HDFS. HDFS stands for Hadoop Distributed File System. Right. So this is one of the storage system, the file system for storing big data. Right. So we have this MapReduce, which is a simplified data processing on large clusters. So here we are bringing this concept of clusters, right, to pull in and put data into this Hadoop architecture as such. Right. So this MapReduce is a very interesting concept we'll be discussing in the coming slides. Okay, so just try to get these terms familiar for those who are very new to these things. Okay, Hadoop, HDFS, MapReduce. So whenever you hear this term MapReduce, it's actually two words combined together, right? Mapping and reducing. Just try to get this understanding, like mapping some entities and then reducing them to have another solution for that particular thing. Okay. Next, we're talking about HBase, right? Apache HBase is a very reliable distributed storage system for structured data, right? So these are the two developers of Hadoop, Doug Cutting and Michael Carafella. So this is all about the history, right? So Doug Cutting and Michael developed Hadoop to support distribution for the Nudge search engine project, which was funded by Yahoo, right? So hope you have this understanding about why Yahoo is the picture, because Yahoo funded project, right? So Yahoo gave the project to Apache, so to a foundation. So the foundation, right, and the milestone of Hadoop as such started with 2008. And in 2009, we had this Avro and Chikwa, right, becoming new members of Hadoop framework. So even now we have this Avro file system, right? In case you Google, you can just find this very famous file systems, right, in focus. And Hadoop HBase Hive some projects are completed in 2010, which adds more computational power to the Hadoop framework. Right. So you can very well understand the enormous work happening nowadays because of these technologies around. Okay. So 2011 Zookeeper was completed. So as the name suggests, Zookeeper it governs the environment as such, the Hadoop environment. Okay. In 2013, we had these versions, right? 1.1.2 and 2.0.3. And then we had Ambari, Cassandra, Mahout, all this being added to the existing one. In 2015, we had Hadoop Yarn, right? So Yarn is a very good concept, right? In Hadoop, it is mainly for resource allocations, and the name is nothing but it's yet another resource negotiator, right? It negotiates for the resource and gives a very clear construction to complete the process. Okay. So we use this term so that we are able to get those nodes running, okay, and the process to be in line. And in 2013, we are talking about Hadoop 3.0. Right? The reason why we are having these Hadoop milestones is just to give us a clarity about. We are not discussing about a very old technology. We are discussing about the very current technology that is really in focus, right? In happening. Saying so, right? There are still some debates saying whether Hadoop is still alive, right? Or is it Hadoop dead and all those things, but we need to have some sort of understanding that Hadoop are the pioneers and still Hadoop is being extensively used in the cloud, right? It's taken to the next revolutionary stages, right? Hope we are clear in this, right? Are we in terms, those who are industry, right? Are we right? Am I right? How Hadoop is now being used, extensively used? I'm sure Shupak is using it, right? Hadoop?
Yeah, my the other team, the data engineering team. But actually, sir, we are phasing out Hadoop according to them.
So
Yeah, I think they are moving
Hadoop
to
is really
GCP.
dying, is it?
Yeah, they're retiring Hadoop. It's more expensive than. I mean, it's expensive to maintain.
But if in case you're talking about even if you're going migrating AWS or Azure, right? Maybe, am I right?
Yeah, GCP. I think mainly
Yeah.
it's because our company is very strict on the server maintenance, right? We have to refresh every. I mean, once the warranty is out, right? So, they also want to reduce the data center footprint. So, yeah, they're moving it to the public cloud. So whatever that can be moved, they'll try to move. This the company direction.
Yeah,
It's not
yeah,
production
you're right,
critical,
because of
to
the
be honest.
cost involved.
It's yeah.
Architectural details that it will be more minimal, right? You need to focus more on because of the IaaS and SaaS and PaaS architecture of cloud, right? And yes,
Yep.
but also you need to be a little more aware that even though we are using cloud, right? Hadoop is still running in the cloud, right? You agree that?
Yeah, I agree.
Okay, thank
But
you.
yeah, I think I need to get more details. I wonder why they'll actually move away from Hadoop. Maybe it's still Hadoop on, in the cloud. But it's just another, they name it differently. I don't know, right? So this is something that I will want to find out tomorrow.
Yes, you're right. How about others? Are we clear? Any doubts? Any things needed to have more clarity on what is Hadoop, something like that? Or is it very new for some? Just trying to get details. Yes, from open source, free. Good.
Just to share, it's like
Okay.
heard from all the introduction of Hadoop is a free open source, and then we build in a commodity hardware. But our company is surveying to moving to a big data ecosystem. The quotation is like nearly 5 million to build up the whole ecosystem. So I don't think it's that maybe it's cheap for Facebook or all the Google big company. But I
Okay.
think for most Malaysia SME, it's not a cheap investment.
the reason why we are putting it as a cheap thing, okay, initially like when we wanted to experiment these things, okay, and there was no reason for having a dedicated servers, right? One, and also based on the exponential growth of the data, that is where this type of challenges has been faced, right? Like how long they can scale up, how big they can scale up, right?
Yeah, why not start with cloud? I think Jukang, right? I think because you get to experiment your data analytics pipeline, all those in cloud first.
Okay, how about
we also-
Jukang? What are the tools that you are going to use? Like, what are tools you have been using now for querying purpose?
Yeah, what's the use case?
Current-
You're using Hive, is it?
yeah. No,
That's wonderful
no,
then.
we are using the basic, the SQL, and also the BI, but currently we are moving to the cloud. But the cloud the cost is like considering how many gigs that you are using per gigs is calculated by the memory that you use. So we are still looking at few solutions, maybe from the AWS, from the SQL, and also the Azure, also one of our considerations. Yeah, but moving to cloud.
Usually this, when you go to cloud, you will always have a mixed mode approach.
Yeah, currently
There's
we
no
are still
single
using
customer or single service provider over there.
yeah, but it's a very tough, difficult. It's a very tough decision for our management to decide which path we have to moving on. But definitely we are going for the cloud, moving all to the cloud lah. Is the final directions. But which services is more suitable? I think we are still surveying for this part.
But that's the future. That is the future.
Yes, it's in
Because
the
now
future.
there are more number of players coming into the cloud.
Yes.
Right. Just like how these tools, like we are having more players now. It's once again like how they're competitive their prices are.
But I think the toughest thing is we also lack of the experienced staff who have handled this type of what we call the technical team. We might need to recruit a new team to maintain all these because this scenario, I think there will be is lack of the professional teams to manage all this data and all the things lah. So the consideration, I think, is quite big move for our company to moving
Sure.
to
Yeah, you're
Yeah,
right.
actually coming from operation team, actually for a company, if there's no existing operation team to support whatever ecosystem, right? Having an on-prem system will be more costly, right? Because you have to hire people to support your hardware and whatnot. So
yeah.
I think
Currently
moving
is
will be
on-prem.
more ideal because you don't have to support the infrastructure in the sense that the data center, database, I mean
Yeah.
the hardware.
Suppose we should pass it all to our vendors or the suppliers to help us to manage that. But what we concerning is there is some issue happen maybe because currently even on-prem we also facing the firewall issue or anything issue, the server down. We still need our IT guy to be standby and to be look into troubleshoot all the issue. So we don't know actually after we moving to the cloud what
No, but
problem
still they will have the help desk from the service provider to help them.
yeah.
Okay, thank you.
But because we are just sharing because I think in future I think many company will moving to the cloud or even to the big data, all the things. Just I don't think our mainly the SME can be afford on this type of cost lah. But maybe for the Maxis, DG, all the big company, I think is a very not that expensive. But for us, I think it's a quite tough decision have to make that to invest
Yeah,
in
it
these.
depends on the company size lah. Agreed. Thank you, June. Okay, good. Right. So this is just to make sure that we are having some introduction on Hadoop milestones. Right. So Related to what is Hadoop then? It's an open source software framework that supports data intensive distributed applications, right? And the main goal is to facilitate storage and processing of large, rapid growing data sets, right? So it is also cater for structured and non-structured data, right? And it's also using simple programming models, right? So that is the reason why we have so much of tools coming, right? Which are helping this Hadoop environment in a very large scale, right? So taking the example like Scoop or Hive as such, when you want to move data from a relational database model into your Hadoop, right? We can use Scoop, or maybe if in case you wanted to move any data from a structured table or from unstructured data, any text or a log file, you can always use Hive, right? So these things are very much helpful in this Hadoop ecosystem because of its high scalability and availability and using commodity hardware, right? With little redundancy and fault tolerance nature, Hadoop is been in focus for a quite long time. And this is the Hadoop framework, right, where we're talking about the servers, right, on top of which Linux sitting, right? And so usually we go with Linux when we are discussing on Hadoop, right, because of the open source nature, right? There's no big doubt. And JVM, right, your Java Virtual Machine, once again, it is helping in HDFS and MapReduce programs, right? So please take note of these two. For storage framework, we are using HDFS. For the processing, we are using MapReduce, right? Are we clear? Can any one of you give the feedback here? Why we use HDFS and why we use MapReduce? Okay, we have some feedback from Lucian. Yes, you're right, Lucian, and from Caleb. Yeah, it's a global risk, understood, but it once again, you can very well see the guidelines given by those cloud providers. Okay, they give very well guided
Actually,
governance packages.
yeah, their availability is very high. It's 99.999%. If you look at the availability, meaning they actually will ensure 99.999% of the time that the system is up. If exceed that, they will have to pay some. I mean, they have to compensate something like that. Anyway, I'm not sure how true it is
Because
on the compensation.
we are paying only by usage of time, right? Both timing as well as the storage.
Yeah, sorry, sir. I've been promoting cloud more than Hadoop.
Okay. Any doubts so far? Like anybody can just give your input on what is HDFS and MapReduce, just to get us understanding. Before going to a small break, we'll have a 5 minutes break, very small break. Can any one of you just put it here in the chat? What is HDFS and what is MapReduce? HDFS physical storage. Okay, everybody, those who have keyboards in your hand, you can just type. Okay, thank you, Ang. Thank you, Dan. HDFS for data storage, MapReduce for processing. Are we clear? Thank you, Jack. Yes, my dear class, are we clear in this? HDFS and MapReduce in Hadoop. What are these two doing in Hadoop?
So can I ask you about this? And Caleb's question. The reason that the AWS they have high availability is because they are using this big data concept, which is they have their distributed storage, and then whenever one storage fails, they have another storage to back up. So they will have a high availability. So they won't have any problem if there's something's happened with their servers or what. Is it?
Is it?
I mean, the question from Caleb is cloud service. It looks like it's supported by AWS, and many companies using AWS services and cloud services.
No. Caleb is thinking about extreme condition. What if blackout happens? What about any solar flare?
But then they have a server center, right? One server center down, they have another server center in another location in the world. So I'm
we
not
have
sure.
different continents. That is true because we have in Antarctica and Arctic. Right.
Thank you, sir. I got it. Thank you.
Thank you. Thank you. And the reason why they put it in Antarctica, Arctic, and Greenland mainly to save energy, right? Because most energy is spent on what you call as the bill, the
I
electricity
think some
bill.
of them, they actually put their data center under the sea, you know, because of the cold.
No, it is actually
They're trying to
still
experiment it.
under for Google. Google has planned it, but I'm not sure whether they have
I'm
enforced
not
it.
sure, not just successful as I know they still tested on that concept.
Mostly they're building in Canada, but I think nowadays you can see Canada is also boiling temperature. Yes, Loction. Distributed file system MapReduce. Thank you, Loction. So I think we have some good understanding here. Okay, class, we can have a small break for 5 minutes. Okay, before we finish this lecture. I need to have this definitions, right, coming across your mind so that when we discuss this, okay, it becomes more easier for us to grab, like the terms like MapReduce, HDFS. Okay, thank you. Okay, please mark your attendance. Okay, has everybody marked? Chu Wayne, Junita, Wan Singh, NG,
Marking, sir.
who's?
Junita here. I'm marking it now.
Okay, Junita. What about others?
Two here.
Unhao. Unhao.
Yeah.
Okay. Wan Singh. Z. Zan. Okay. Kindly mark your attendance. Chityo Kalib, Crystal, NGB, B Chen, Raymond Ko, Yong V, okay. Chu Park. Samra Wong.
Hi, sir. Wang Meiqi is here.
Okay. Samra Mirza.
Sir, I think my connection was bad.
Okay.
Yeah, Park Chuan here.
Park Chuan, I mark your attendance. Don't worry.
Okay, sure. Thanks.
Sir, can you take my attendance just now? I was away.
Okay. You're from ODL or PT?
PT.
Your good name?
I think not here. Normally it's the first one. The first class. Yeah. Number 5.
Hello, sir. I'm number 4. Can you?
Sir. Just now the one, yeah, number 5. Okay, thank you, sir.
Hello, sir. Yeah.
Yes.
Yeah, Guan Wen-Seng here is here.
Okay. Okay, thank you. We'll go to lecture. Right, so this is the typical framework, right, where we have the tools, right, that actually makes the Hadoop. So we are talking about HDFS and MapReduce in a big fashion because it is the main heart and soul of the Hadoop, right? Because where we store the data and then how data processing is happening. Okay. So through data storage, we're talking about HDFS, and through MapReduce, talking about data processing. So when you're talking about HDFS, right, please take note of how we are using other data access frameworks, right? So we use big scripts, Hive SQL or Scoop, right? Or Avro for this type of accessing from data storage, right? And then we have the orchestra like HBase, Chukwa, Flume, Zookeeper, right? That can actually help in what we call as in a way for bringing structured and unstructured data into more focus and more clarity, and also for automation purpose, right? Using Flume, I'm sure if in case those who are already working, anybody working in Flume? No, nobody. Okay, so maybe you can later just have a idea on this tool. These tools are very helpful. Okay, that is the reason why these are put under this orchestration framework. Okay, helping to have this data warehouse connectors, right, for facilitating data input and data output, right, through these tools. Okay, and then we have the backup and recovery, deployment, security, and management that can be done with help of the Hadoop framework. So Hadoop architecture as such is a distributed with some centralization, and it's a main node of clusters where most of the computational power, right, and storage of system lies. Okay, so the concept of nodes, right, is highly to be noted in this culture, right? We call it as name node and data node. There are two types of node in any cluster, name node and data node. We can discuss that in the further chapters. These two are mainly for having an understanding about where data is being stored and correctly to know, right, the information about the data. Okay, because of the nomenclature of having data among clusters, right, in Hadoop, we need to have this type of understanding about nodes. So main node of clusters are where most of the computational power and storage of the system lies. Okay, so the main node runs a task tracker to accept and reply to MapReduce, and also a data node to store needed block as closely as possible. Okay, so these name nodes actually keep track of the HDFS directories and files. Okay, so the question is, why do we need to have a track of HDFS? Right? Why do you need to have a track of HDFS? We know that HDFS is nothing but it's a data storage. Do we need to have a track of the HDFS? So this is mainly to ensure that we are aware of what is being stored in HDFS. Right? Are we clear? Yes, Angpao. Metadata is one good concept, right? Where we can have the data about where these nodes resides. Right? So metadata is actually used as a file, right, in name nodes. Right? We use some registries in the name node to have details about this data in the data nodes. Right? Is it clear? Okay, fine. How about others? Are we clear? Okay, fine. Thank you. If any doubts, please you can put it in the chat so we can have discussion. So just to have this understanding, we have these task trackers, we have data nodes, and then we have name nodes. Okay. So these are in Java, right? And they can support Python and Ruby. So this is an Hadoop architecture, right? So we have some switch. This switch are just basically to connect the different clusters. So what we say is rack on rack 2, nothing but clusters of systems like the commodity hardwares, and each racks will have its dedicated name nodes, right? They have job trackers, right? As what needs to be done based on the process. Okay, so this is a typical Hadoop architecture. So Hadoop distributed file system HDFS is tailored to meet the needs of MapReduce, right? To meet needs of MapReduce in the sense to help facilitate the process, right? So it is targeted towards many needs of file streams, right? Writes are more costly. Writes are more costly and higher degree of data replication, the 3x by default. No need for RAID or normal nodes. Large block size, 64 MB, right? And location awareness of data nodes in network. Excuse me, I need to. Yes. Okay, so writes are costly. Why do we say writes are costly? Anyone? Did we discuss about schema on read and schema on write? Very good. Yes, on. So write once and read many. Okay. Do we have this clarification on read? Schema on read and schema on write? So in a typical database, do we use schema on write or schema on read? So when you design a database, because I think all of you should have studied database, right? Okay. You already will write a schema, right? Use a DDL, you write a schema, and once written, then you start inputting the values. So this is going to be schema on write. Once it is written, what we can do, we can use queries to read it. Right? Whereas in real time, if in case you're going to write it, or you're going to use this schema on write, it is more costly because we are not aware of what is the data stream that you're going to encounter, right? So we need to just dump in all the data, and then later on we can use the read schema to read those data. Are we clear in this? That's the reason why we use this statement. It is costly. Anybody having any doubt on this? Can move on. Yes, class. Okay, fine. Okay. So these are default, right? By large size 64 MB, right? So that you are able to store large volume of data, right? Okay. And location awareness data nodes network is to know that where we are storing the data. So in Hadoop architecture, we have name nodes, right? So we have name nodes, and then we have a data node, right? So you can very well see that data node is governing the name node. Oh, I think I'm already sleeping, right? We have name node and then we have data node. Right. So name node actually stores the metadata of the file. It doesn't contain the data, right? Data is actually in the data node. The name node only has the metadata. Okay, please don't forget. Okay, the server holding the name node instance is quite crucial as there is only one. Right, it should be only one. So name node we have only one. Other data nodes we can have n numbers. Right? And how do they keep track of name node? And data node keeps track by using some sort of mechanism where data nodes use some sort of a signal to initiate some sort of a dialogue saying that he is alive, right? The data node is alive, right? And then name node will initiate the process of getting what is to be done. So the transaction log of the file, right, deletes, etc., are actually stored in this metadata. It can create more replica blocks when necessary, right? And once again, based on a data node failure. Please take note of it. And data node actually stores the actual data, right? Please take note. Name node is a metadata. Data node stores the actual data, right? So it can run on any underlying file system, right? It could be an extension 3x4 or your NTFS, your Windows file system, or anything like that. And it notifies name node of what block it has, right? So name node replicates blocks 2x in local rack. 2x in the sense it replicates twice in its local rack and 1x elsewhere. Elsewhere in the sense maybe in a foreign location, maybe in a distant location, in a remote location, right? So this is a typical Hadoop architecture of a map reduce engine. All right. So here we are discussing about the different jobs that is being posted, and the jobs are actually split, right? And then they are given to the mapper, which once again is being sorted out by a tasker, right? And then they are produced as an output. Okay, so we are mainly concerned about what is the job, it's a job submitted, what is the task tracker doing, right? And how the task tracker is facilitating the job of map phase and reduce phase. Right, we can very well see here this diagram. In map phase, we have a mapper that can combine and partition. In task phase, we have something called as a sorter, which sorts and then reduces. So this is just a typical architecture. We'll have an understanding on this in a very detailed one. Okay, I'm sure. Okay. Maybe I can give you the particular diagram maybe later in the chat. So this is the typical name node and data node. Right, name node where metadata consisting of the names, how many replicas it's made, and all those details, right? And the data nodes, which consist of the different data blocks, right? Are we clear so far? Any doubts? Hope nobody's tired, right? Everybody's okay. MapReduce usually is a process, right, which is actually run in the background using JVM, Java Virtual Machine. But you can run MapReduce through other languages. You can also use Python, or you can also use Spark, PySpark to run any MapReduce job. Okay, Khalid. Are you clear now? Thank you. Hope others are clear.
So is it MapReduce? I think MapReduce is using Java, right?
Yes.
So
JVM.
if you want to communicate with the MapReduce, we need to use other tools like Hive or what to communicate with the MapReduce, is it?
No, MapReduce as such, okay, it's a process. Okay, what Khalid was asking is like, if in case MapReduce, we want to do a release MapReduce job. Okay, what language can we use? MapReduce as such, when you are doing any process in Hadoop, this MapReduce will be done only in the JVM platform, because only Java is going to be running in the background. But as a program, if in case you want to run any program, you can use PySpark or Python. Is it clear?
Got it, sir. Thank you.
Okay, thank you. So in MapReduce engine, right, we have job tracker and task tracker. So job tracker splits data into smaller task, right? Map, that's what we call as a map, and sends it to the task tracker, which processes it in each node. And the task tracker reports back to the job tracker node. And this is a job process that sends reduce request to have new jobs. And the typical Hadoop architecture, none of these components are necessarily limited to using only HDFS. Many other distributed file systems are also quite used, right? So many other software packages beside Hadoop MapReduce platform also make use of HDFS, right? This is what I've been discussing about different types of tools with the Hadoop environment. So Hadoop is used at most organizations that handle big data, like Yahoo, Facebook, Amazon, Netflix, right? And some of the examples of how they are being used is something like Yahoo search, right? When they're doing the Yahoo search, it can run up to 10,000 core Linux clusters. Right? We're talking about commodity hardware, and this is what we are talking about, like whether it is really commodity and how well we can scale up that large amount of different hardwares, right? Because imagine 10,000 core next clusters, like how many systems you will be using if in case it's just 10,000 core, even if one system is having 2 core or a quad core. Right. So Facebook Hadoop cluster hosts 100 plus petabyte of data just in July 2012. So what about now? Right. So this is the exponential growth of data. So the three main applications of Hadoop, like for advertisements, for search, and for security. Right. So Hadoop in the wild, mainly for non-real-time large data set computing, dynamically can generate PDFs of articles, and for relatively this number of years, it did not take much long time. So there is, these things are just mainly given for our readers to have a what we call as a background search. Okay, maybe you can later search on this particular article, like New York Times dynamically generating PDF of articles. How long did it take to generate PDF of this long number of years? Right, using Hadoop. Similarly, wanted to pre-generate and statistically serve articles to improve performance using Hadoop and MapReduce running on a EC2. Right. This EC2, S3, all these things are actually mostly cloud, right? Sure, all of you who are cloud are aware of this. Right. Are you still using EC2 or your anything else? Those in cloud. Right. So all these things are mainly for what we call as elastic storage and this secure storage and all those things, right? Okay. So in Hadoop in the wild, how they are being used in Facebook, right? So integrating different processes like display of email, SMS, chat messages between pairs and group of users, controlling or taking control of other processes like receiving messages. Okay, all these are possible, right? Were being made possible because of the nature of Hadoop. But initially, it was how it was being done. Right. It is also mainly because of the high write throughput. So these things can be written as the advantage of Hadoop. Okay, please take note of it. Advantage of Hadoop. High write throughput, cheap elastic storage, low latency, high consistency, right? Which is a very good thing, right? Within a single data center, how well we are able to get those data. And the disk efficient, sequential, and random read performance. Right. So what is the classic alternative? Okay. So this requirements typically meet using large MySQL clusters and caching using memcached, right? So this memcache is actually what is called as a technical term, right? Which is used in terms of memory. Okay, the memory that is residing very close to the processor. Right? So those memory that reside very close to the processor usually has more accessing, right? Which is more easy to produce the real data. So the contents on HDFS could be loaded into MySQL or memcached if needed by a web tie-up, which actually makes it more faster. So the problems with the previous solution was MySQL has low random write throughput. So what is the meaning of this low random write throughput? Any idea about this? Those I'm sure these things you have studied in your database. Why do we say this MySQL has a low random write throughput? So when do we actually discuss with throughput? When talking about latency, when talking about data communication, when do we actually go with this throughput? Or how do we actually measure this, saying that MySQL is having a low random write throughput? Okay, processing power. Okay. Any other technical details? Okay, NZ. Yes. Right. This is the expectation. So it is slow in writing data in database due to the schema and write. And it is not about parallel processing. Right. This is the reason why we are talking about this. So this is a big problem for message. So difficult to scale is also because of this, and MySQL clusters have high management overhead, and it is also a very expensive hardware. So this is the reason why there was a high expectation and the reason how Hadoop was actually floating big in the market, right? So Facebook solution was Hadoop plus HBase and improve and by adapting HDFS and HBase to scale Facebook's overload. So these are actually some of the reasons, right? How they have been using in the real time, like the other reasons like failover times, okay, 24/7 uptime requirements, right? Rather performance improvement. So all these things are trying to give us a detail about the improvement, right? It has been made. So the highlight is Hadoop is a distributed file system. Fault tolerance is available. It's open data format, has a flexible schema, right? Because we are talking about schema on read, right? And we have a queryable database, which is a Hive. So in next class, we will be discussing on Hive. So this is mainly to have focus on Hadoop. So why did we use Hadoop? To process high volume of data set, right? Where data may not have any strict schema to write. And expensive to build reliability in applications where node failures happening, having a common infrastructure, very large distributed file system, assumes commodity hardware, right? Batch processing and running on a heterogeneous OS. Okay. Okay, can we continue for the next 10 more minutes? Is it okay? We have another few more slides. Let's just check this number of slides. Yeah. It not take more than 10 minutes. So this is some of the slides. I once again repeat it to you because to make sure that we are just making us reminding about what we discussed. So data node is a block server that stores data in the local file system, right? Stores metadata of a block checksum. Serves data and metadata to clients. And the block report periodically sends a report of all existing block to a name node, and it facilitates pipelining of data, which means data to other specified data nodes. So what is a block placement? So we have what is called as a replication strategy. Replication strategy in the sense, if in one data node fails, it is automatically replicated, right? So that data is always safeguarded. So any particular data is always replicated twice, two locally in one in a remote place, right? So one replica on local node, second replica on a remote track, third replica on a same remote track or something like that. Additional replicas are randomly placed if in case it is programmed. Okay, the client read from the nearest replica so that we are getting the fastest data. So data correctness is used to checksum to validate data, and file creation usually computes checksum for 512 bytes. So this is actually some sort of a data that is actually randomized. Okay, and data node stores the checksum. So regarding file access, client retrieves data and checksum from the data node. Okay, so these are some hardware things that we need to remember. Okay, and the architectural details and these type of things should always be remembered. Okay, there is this is some of the things when we talk about theoretical aspect. Okay, so if validation fails, client tries other replica because of the data correctness. So data pipelining. Why we need pipelining? Because to bring data from the source to the sink, right? So client retrieves a list of data nodes on which to place a replica of a block, and the client writes block to the first data node. The first data node forwards the data to the next data node of the pipeline, right? So it's typically how in any data lake, right? We are using a pipeline, and when all replicas are written, the client moves on to write the next block in the file. So Hadoop MapReduce is a programming model for distributed processing of large data set. Okay, so these are some commands just for your reference. Okay, because we're not using any demo here. Okay, so these are some common design patterns and data processing when you wanted to map and reduce, right? So MapReduce usually has a log processing, has a web search indexing, and ad hoc queries, right? So these are the three important usage of a MapReduce. Okay, log processing, web search indexing, and ad hoc queries. So because you are focusing on this MapReduce, okay, on terms of usage, okay, when discussing about log processing or web search indexing or ad hoc queries, okay, here we are mainly discussing on the processing that is taking place, right? When any log process is happening or when a web search indexing or ad hoc queries is happening. Okay, maybe we can take this as an examples of a MapReduce process. Right? Are we clear in this? This is a typical example of a MapReduce. Yes, from Lokshan, what is the meaning of checksum? Okay, checksum is actually some architectural design details that we usually use. Okay, like parity bits, flags, checksums. Okay, these things we use to make sure that architecturally we are talking about whether these data are really being transferred. Right. If in case we are talking about data being transferred in bits, right, we use this type of checksums, right? Or we also use flags to take note of the details about any process. Okay, these are some architectural designs that you're used in processings. Okay, Lokshan, nothing too much to worry about those checksums. And from Angpao, big data storage processing. we tend to promote Hadoop as far as, with some rich countries like US supercomputers. And even use it to prediction. My question is, what is the difference between Hadoop and supercomputer? I know this is super expensive too. Okay. I'm not. I don't want to dive into this question now. Reason because it's not about supercomputer in focus, right? We are talking about quantum computers. Okay. So when comparing quantum computer and supercomputer is baby, right? Angpo, do you agree?
Yes, sir. Quantum computer is the latest term that they're being used.
Okay. And relatively, when quantum computing is going to be in focus, right? What about security? What about the encryption? Right? It doesn't take seconds to encrypt any data, right? So that comes whether it's going to be 128-bit or 256-bit of encryption that you're going to use. So there are some more researches happening, right, exponentially when we talk about these technologies in hand. Okay, and talking about supercomputer and Hadoop, it's way two different type of technologies that we're talking about. Supercomputer is mainly for number crunching and Hadoop is mainly for storing data. Am I clear, Angpa? Okay, thank you. Okay, this I'm sure all of you are able to understand this MapReduce usage. This is something like a case study, right? Where MapReduce can be used because of its processing, mapping and reducing concept, right? Are we clear, my dear students? Are we clear, my dear class? Okay, hope others may need some time to just read the documents and do. Okay, fine. Okay, fine. So this is going to be our last slide. Okay, thank you for being patient enough. So before it was like data source, ETL, right? Data warehouse and business intelligence. So offloading data warehouse to Hadoop, what we are doing now is, right? With ETL, we are also introducing Hadoop, by which what happens? It becomes more easier because we are dumping in data and then later on we use our schemas to read, which makes it more easier for querying and reporting. Right? How we shifted ETL process from data warehousing, right? Completely in ETL. So what happens in data warehousing? It becomes more easier for our process, right? I know it takes some time for you to digest. Please make sure that you revise once again these concepts. If in any case, any doubts, we can discuss in next class, no issues, but just make sure that you revise these concepts. Right? Am I clear, my dear class? Any doubts, you can post it here now, or thank you, Ang. Okay, class, then. Good night. Okay. Is Hadoop part of the test topic? Yes, it's part of the test topic because it's about data storage, right? Okay, thank you. Thank you, dear class. Good day and good night. Okay, so kindly prepare for the test, both mock test and final test. Thank you. Thank you, everyone. Okay, stop the recording.